Alright, let's begin. So in order to understand the exponential graph, first of all, you need to know the standard form. So let's talk about the standard form. So the standard form of the exponential graph is a b x minus p. So it's a b to the power of x minus p plus q. So first of all, you have to memorize that the original shape of the exponential graph. So let's just say this is our Cartesian plane. So you have to memorize that this is the original shape of the exponential graph. So the original shape of the exponential graph is something like this, right? So think of this as the original. Alright, so now this original shape happens whenever b, so b is whatever is carrying the exponent. Let's talk about b. So for instance, if b is something like this, right? So let's just do this. Okay, let me just do this. So notice that b, so let's make this 5. So let's just say this is our equation. So whenever b is bigger than 1, right? So b is what is carrying the exponent. So whenever b is bigger than 1, this is how the graph is going to look like. So it's going to be the original shape, right? But now, if b is a fraction, so if we have something like this, for instance, 1 over 2, and they'll put it all in brackets, right, because the exponent has to cover everything. So now, if it is a fraction, then the graph is now going to be shaped this way, right? So it's going to be a decreasing function this time. So this is what we're going to have. So now, if b is positive, then it's going to be the original. But if, okay, not positive, I mean, but if b is bigger than 1, then it's going to be like this, right? But if b is a fraction, then it's going to be like that. So now, why am I not saying that if b is not a fraction? Why did I not say that if b is not a fraction, it's going to be original? Okay, so now, because b can also be an improper fraction, so if they really want to test it, they'll do this, right? So if b is an improper fraction, it is still the original. So basically, if b is an improper fraction, it's going to be the original. But if b is a proper fraction, it's going to be the decreasing version, right? So this original number, or rather this whole number, is also the same as a an improper fraction. So 2 is just like 2 over 1. So basically, if it is an improper fraction, it is the original shape. But if it is a proper fraction, then it is the decreasing function. So that's the first thing. Now let's talk about a. So a determines whether it's going to be original like this or whether it's going to be reflected in the x-axis. So let me give you an example. So let's just do a small example. So let's just do this. Let me just rather do this. So let's just say we've got a certain graph. So let's just say we've got something like this. So if we want to draw a rough sketch of it, or if we want to predict how the shape will look like, this is what's going to happen. So we already see that this is an improper fraction. So because it's an improper fraction, we already know that it's going to be the original. But now we have to look at a, right, in order to determine whether it must stay like this or whether it must be the reflection of this in the x-axis, right? So basically, how do we tell? If a is positive, then it's going to stay the same. But if a is negative, then it's going to be the reflection in the x-axis. So if we have negative, for instance, in this case, then we know it's going to be something like this, right? So that's how it's going to be. All right, let's go for another example. Let's say we have a certain graph. So let's just say we've got something, something like this, half, and let's say this is x, and let's just say this is plus q. All right, so now how is this graph going to look like? Okay, so let's just make it negative. All right, so this is what we're going to do. So we know that since this is a fraction, it's the decreasing version, right? So afterwards, we now have to look at a. Should it stay the same or should it be the reflection in the x-axis? Well, if it was positive, it would have stayed the same. It would have been like this. But now that it's negative, we know that we have to reflect it in the x-axis. So it means it has to be like this. So basically, this is what we have. So the graph, this graph that is drawn is actually this graph, right? So this is how it should look like. So I'm just going to do two more examples, then I go to some crazy level that a lot of people don't know about. So let's just do that before I go to a crazy level. So let's just do two more examples. So here is something, something like this. So something like this. Okay, let's talk about Q. So let's just sort of got our Cartesian plane. So how is this graph going to look like? You can even pause the video and you can predict how the graph will look like, and let's compare. So this is a normal number, so we know that it's supposed to be increasing, right? However, this is negative, so this tells me that I have to reflect it on the x-axis, so it's going to be like this. So this is how the graph will look like. All right, let's just go for the last example before I go to a crazy level. So uh, let's just go for a last example. So here is something 1 over 3 and then x, let's just say plus q. So how will this graph look like? You can pause the video and then you can draw, and let's compare. So this is how the graph is going to look like. So here's our Cartesian plane. So we see that this is a fraction. So because it's a fraction, it's going to decrease, right? So it's the decreasing version of the graph. And then notice that a is positive, so we're not going to reflect it on the x-axis, right? We're just going to leave it like this. So it means that this is going to be the shape of the graph. All right, so now let's go to level 2.
Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEB, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvement.
If you're interested in knowing the prices, the video that contains the prices and the updated contact details, just in case these ones have changed, is found at the end of this video. So let's talk about something that a lot of people don't know about, right? So let's talk about that. All right, so now we've got a problem. What if they give you a graph like this and they say minus x? So what does this mean? This now tells us that it's going to be the opposite, because let me show you what I mean. Notice that if I were to simplify this, this is exactly the same as having 1 over 2 to the power of x, right? Because 2 to the power of negative x is 1 over 2 to the power of x. But now 1 to the power of anything is 1, so I am allowed to put x here, and I'm not breaking the rules. It's still correct. But now this is actually the same as me doing this, right? Because this bracket means that this x belongs to 1 and it also belongs to 2. But you don't have to worry about this procedure. All you have to know is that whenever there is a negative exponent, if it is an improper fraction, it is now a proper fraction, right? So that is it, literally. Or if we have something like this, for instance, if we put this but now it's no more to the power of x, but now it's to the power of negative x, it means that since this is a proper fraction, it's now going to be an improper fraction. Because this we can simplify it, right? Not that you have to do that, but okay, in some cases, yeah, you can do that in the exam. It's helpful. They accept all forms. So if your answer was supposed to remain like this, in the memorandum you'll see they'll give you the option where it's like this, and they'll give you the option of simplifying, so you can do anything you want. So if we simplify this, notice that this is just the same as 2 to the power of negative 1 in brackets, right? So now there's negative x. So now notice if I multiply this, it's just going to be 2 to the power of x. So therefore, if I see a proper fraction, I take it as an improper fraction whenever x is negative. So let's now practice just 2 questions of this graph, right? This particular one. So let's practice 2 questions of it. All right. So now, when you see the question, you can pause the video and then we'll compare, right? So here is a situation. So let's just do this. Let's just do this. So you can pause the video and predict how this graph will look like. So now, here's a Cartesian plane. So something like this. So this is a proper fraction because it is an improper fraction, yet we've got negative x, so we have to take it as a proper fraction. So we know that when it's a proper fraction, this is going to be the shape of the graph. However, negative, a is negative, it tells us that we have to reflect it to this side, so this is going to be the shape. So therefore the correct shape is just this, right? So because this is the reflection of the decreasing version. All right, so now let's go for the last example, but I notice I have to talk about something important, right? So remember the full form of the exponential graph is y is equals to a b to the power of x minus p plus q. So q represents the horizontal asymptote, right? So for instance, if you have got a certain graph, let's just say we've got, let's say this is, so let's just go for the last example. So let's just do this. So let's just say we've got something, right? So let's just say we've got minus, and then let's say we've got half, and then we've got minus x. Let's just say plus 1, and then plus 2. So 2 is going to be the horizontal asymptote. So when you draw the exponential graph, you always start with the horizontal asymptote. So it's going to be at 2. So 2 is going to be somewhere there, right? It's not about accuracy, it's just about estimation, because they actually will say sketch instead of draw. So you tell them y is equals to 2. So this is going to be your asymptote. And then now we know that, okay, so this tells us that it has to be a proper fraction, so it was supposed to be like that. But now we have negative x, meaning that it's going to actually be an improper fraction. So it's actually original. Now we have to look at a. Is it going to stay the same or is it going to be reflected? It's actually going to be reflected, right? So, okay, let's just do this. So it's going to be reflected because a is negative, right? So it means that it's going to be like this. So this is the original shape. I mean, this is the shape of the graph. So there we have it. So what is the significance of P? P only tells us the horizontal shift. So P does not really play a role in this stuff. Yeah. So what you have to understand is just P, which tells us if it is a whole number or an improper fraction, it goes like that. But if it is a proper fraction, it goes like that. And then A tells us whether it should stay the same or should be reflected. And then Q is the horizontal asymptote. Yeah, P is just horizontal shift and stuff, but yeah, um, just for understanding's sake, let's just leave it there. All right, great.